In this tutorial, we are going to talk about two new features that take VR assembly to a whole new level, which are the utilization of subassembly and the ability to have a custom assembly component that is controlled through the training builder. What we have in the scene is a reducer, which we are going to disassemble using the VR assembly system. Let's talk about the order of which the components are going to be removed. First, we are going to remove the cover. I'm going to select it and press H on the keyboard to hide it and reveal the components beneath it. Next, we are going to remove the inner components together as a single component or a subassembly. Then we need to take them apart one by one until we reach the rusty gear. Once we remove the rusty gear, we are going to install the new gear, then put the components back in the same order. Let's first create the subassembly. We are going to select all the components that are going to move as a subassembly, and from the objects tree, right-click and select Add Parent. Rename the newly created parent to a suitable name. This is it for setting up a subassembly. Next, we are going to create the VR assembly system. From the Interactions menu, select VR Assembly System. The first component that we are going to remove during the VR experience is the cover, so select the cover and drag it into the VR assembly diagram to add it as the first component in the assembly system. I'm going to press H on the keyboard to hide the cover and gain access to the components behind it. The next component to remove is the whole subassembly we created, so select it from the object tree and add it to the diagram and connect the cover node to it. Once the whole shaft is removed from the reducer, we can take it apart one component at a time, starting with the retainer, so add it to the diagram and attach it right after the subassembly. Again, I will press H on the keyboard to hide the part. And next we will add the bearing. Select the bearing component and add it to the diagram, then hide it. Right behind the bearing is a spacer, so select the spacer and add it to the diagram and connect it to the assembly chain. And lastly, we are going to add the rusty gear as the last component in the VR assembly system, so add it and connect it to the spacer node. To be able to replace one component with another, we need to define them both as a single component type. Click on the Assembly Tools and Components button and go to the Components definition. Type a new component type in the field and press Enter to create it. Then select the newly created component type, and from the object tree, select both the rusty gear component and the new component sitting on the table and add them both to the components type list. We are not going to be using tools for the removal, so leave the tools option blank. Once multiple components are defined as a similar type, that can be used interchangeably within the VR assembly system. Before running the VR experience to test out our progress, make sure you select the highest level of the reducer assembly and press S on the keyboard to show all the components that we previously hid. From the VR Viewer menu, select Show in Viewer, then select Desktop Mode. As you can see, right after removing the cover, the user has to remove the whole subassembly, and then he can start removing the components one by one. Similarly, place the components back together following the same order, with the subassembly being put as a single component before placing the cover back on. In the second part of the tutorial, we are going to talk about custom components. Custom components allow designers to define specific conditions under which a component can be assembled or removed. These conditions can be set using the training builder, enabling the integration of more complex procedures and interactive tools into the VR assembly system. In most mechanical designs, bearings are usually removed using a puller or a hydraulic press, since they are usually tightly fit. In our example, we are going to use a bearing puller to remove the bearing instead of just removing it by hand through the custom component feature. If you were to go to the Sequences tab in the bottom panel, you will find an animation sequence for the bearing puller, and we are going to utilize this animation in the custom component interaction. Setting up the use of the bearing puller can be divided into two aspects. First is a visual aspect where the puller needs to be placed at the shaft and for the bearing to be pulled out when the animation plays. And the other aspect is setting up the training builder's logic. We are going to begin with the visual aspect. Select the jaw puller and press in on the keyboard and click on the shaft to snap the puller in that location. Then try to position it as if it were in contact with the shaft at the center. Select the base of the bearing puller. The base of the bearing puller remains in contact with the shaft, and the jaws are retracted, pulling out the bearing while moving. What we are going to do now is to animate the bearing as if it were being pulled by the jaws. Hold Shift and click to add to the selection the bearing assembly at the level named front bearing_anim. The reason for selecting a level lower than the assembly level is that we are later going to use scene states at the top level to place the bearing back in its place during the assembly process. With both the base and the bearing selected, go to the Animation tab and move the current time slider to frame 40, which is the frame where the pulling animation starts. Since we have selected both the puller and the bearing, you can see that we can view and adjust the animation for both of those objects. Now click on the front bearing tab in the animation timeline to select it, then click Capture Keyframe. Move the time slider to frame 130, which is the last frame in the animation, and move the bearing to keep it within the grasp of the puller jaws. Adjust the bearing's animation to match the component's animation as much as possible, and once you are done, select the highest level of the puller assembly and the bearing assembly to reveal the keyframes for the whole complete animation. Click on Select All Keyframes button, then click on Create Animation Sequence, type in a name for the animation and click OK. You can go to the Sequences tab and play the recently created animation sequence. The next thing that we are going to do is to establish the method for placing the bearing puller onto the shaft before we get to play the animation sequence, and to do that, we are going to use the Snap and Socket tool. With the bearing puller selected, press I on the keyboard to isolate the selection. From the Interactions menu, select Snap and Socket. Make sure you disable the option to automatically place sockets, since we only need one socket, and leave the rest of the options at their default value, and then click Add Socket. This socket that has been created will serve as a magnet, where it can attach to other objects with sockets in them, and to determine the direction of attachment it uses the red arrow's direction. So what we need to do now is to place the socket's red arrow at the center of the circular base and ensure that it points outwards, and to do that we are going to use the Align tool. From the Move menu, select Align. Now we need to set point 1 as the center of the red arrow's base, so click on the Selection Type menu and select Pick Edge Loop. Select the base of the red arrow and then click the color which represents the square base, which in this case is green. As for point 2, we need to select the circular base of the bearing puller, so change the selection type to Pick Center of Curvature, then click on the circular edge at the base. Now that we have selected the 2 points, click Apply to align the socket to the base of the puller. If the object was facing the opposite direction, simply click Flip to adjust its orientation. As you can see, the arrow is not pointing outwards from the center of the base of the puller. We have now successfully placed a socket on the bearing puller, and we can move it to the side next to the reducer and move on to placing a socket on the shaft where the puller will be placed. Similar to what we did before, select the shaft body and from the Interactions menu select Snap and Socket. Keep the settings as they are, but toggle off the option to make the object grabbable, since the shaft grabbing will be determined by the VR assembly system, and then click Add Socket. Same as before, we need to align the red arrow with the center of the shaft and make sure it's pointing outwards. From the Move menu select Align. Change the selection type to Edge Loop and click at the base of the red arrow, then select the color representing the loop at the edge. For the second point, switch the selection type to Center of Curvature and click on the loop at the edge of the shaft, then click Apply. Feel free to flip the socket if it was pointing inwards instead of outwards. Now that we have an additional socket at the shaft, the puller should be able to stick to it easily during the VR experience. Let's run the VR experience and test it out. Grab the puller, and notice that once it gets in proximity of the shaft, a ghost indicator of the puller would automatically appear in its place. And upon bringing the puller into the ghost indicator and releasing the grab, the puller would be positioned there in accordance with the socket's positions. Go back to SimLab Composer. The last part of the visual aspect that we need to take care of is to be able to place the bearing back on the shaft, and to do that, we are going to be using scene states. Scene states simply capture the properties of an object and applies them whenever that scene state is applied. Select the front bearing assembly at the highest level and go to the Scene States tab and click on Capture Scene State. Type in a name for the scene state and make sure that only the Transform and the Animate options are selected, and click Capture. Now, if the bearing were to be moved during the disassembly process, it can be placed back on the shaft by applying the scene state. We are done with the visual aspect of creating this custom method of removing the bearing, and we need to go to the second aspect, which is setting up the training builder logic to control the assembly. And the first thing we need to do is to set the bearing as a custom component. Go to the Interactions menu and select VR Assembly System. Click on the Tools and Components icon and go to the last tab named Custom Components. Select the front bearing component from the object tree in SimLab Composer and then click on Add Custom Component. Notice that a slightly different icon has been given to the front bearing in the object tree, indicating that it now has a special status as a custom component. Now we move to the second aspect, which is setting up the training builder, so open the training builder. Looking at the components we have, we know that the bearing puller should be snapped at the shaft after the gear retainer has been disassembled. Right-click in the Training Builder diagram and select Events, then Snapping, and select Snapped. Now select the bearing puller from the object tree and attach it to the event. This event would trigger responses once the bearing puller is snapped to any sockets, and since we only have one additional socket, we do not need to determine which socket it is. Add a play sequence response, then go to the Animation tab and select the animation where the puller and the bearing are animated and attach it to the response. Next, we need to tell the assembly system that once the animation is played, consider the bearing to be disassembled, so right-click in the Training Builder and from the Responses menu, select Scene Node, then select Assembly, then select Set Assembly State. Keep in mind that when dealing with custom components, it is upon you to decide when to set the custom component state as assembled or disassembled. Select the front bearing and attach it to the assembly state response and change the state to fully disassembled. Connect the responses to the event. Add a change grabbable state response since we need the bearing to become grabbable once removed, and attach the front bearing to the response. Now, if we were to connect all the responses to the event, the front bearing will become grabbable and considered disassembled the moment the puller is snapped into position. But what we want is for the bearing to become grabbable once the animation is over, so what we are going to do is create a sequence-ended event and attach the bearing removal animation to it. Then connect the event to the assembly state and the grabbable state responses. What we have created so far does not ensure that the bearing can only be removed after the retainer has been removed. To introduce the condition of a component removal, right-click in the Training Builder diagram, and from the States menu select Assembly, then select Node Fully Disassembled. Attach the gear retainer to the state node, then connect the output Boolean channel to the node snapped events Boolean channel. What we now have is a system where once the gear retainer has been disassembled, and when the bearing puller is snapped onto the shaft, the pulling animation will start, and once the animation has ended, the bearing state will become fully disassembled, which in turn will allow the following component in the VR assembly system, which is the spacer, to be removed, and the bearing can also be grabbed. Before running the VR experience, make sure you display any hidden components, then run the VR experience. Now, if we were to place the bearing puller, you would notice that the animation won't play, since we have constrained it by requiring the retainer to first be removed for the event to work. Remove the cover, then take out the sub-assembly out of the reducer's box, then remove the retainer. Notice how the bearing cannot be removed right after the retainer, since it is a custom component. Place the bearing puller on the shaft. Once the animation is complete, remove the bearing puller and then remove the bearing from the shaft. Proceeding with the remainder of the disassembly process remains unchanged, but when we get to assembling the parts again, you will notice that the bearing cannot be assembled since we didn't set up the Training Builder's logic for the assembly of that custom component. Go back to SimLab Composer. Let's first hide the cover again to expose the components behind it. Now we need to create an event that once the spacer is installed, the bearing can be put back in place, using a response that places the bearing in its original place once it touches the shaft. In the Training Builder, go to the Second Events tab, and add a Node Enter Node event, and attach the front bearing as the first node. Now from the shaft assembly, select the shaft body and attach it to the event as the second scene node. Add an Apply Scene State response, and from the Responses tab, add the bearing placement scene state and attach it to the response, then connect the event to the response. We also need to set the state for the bearing as fully assembled and for the grabbing state to be disabled, so let's select both responses, and press Ctrl and C then Ctrl and V on the keyboard to duplicate them. Then connect the copied responses to the scene state response. Now change the assembly state to fully disassembled, and the grabbing state to false. Run the VR experience to see the final result.